presentata da Danfoss. Prego.
Thank you, and thank you for giving me the opportunity to come here and speak today. My name is Torben Funder Christensen. I come from Danfoss, and I'm heading up our public industry affairs department within our cooling segment. Just to link to some of the previous presentations, was said that our industry within refrigeration uses 17% of all electricity. Supermarkets use up to 4%. I think that's a very high number. I have maybe a little bit lower number, but still a considerable amount for one sector. We know electricity is an energy source that is increasingly used in society, but also an energy source that we have to take very much care of in the way how we produce electricity. And that is actually reflected very much in different legislation from the Commission side, and we also see that in many other reasons how electricity problems are increasing, especially with peak demands, congestion of the grid, and so on. So why shouldn't our industry be able to really contribute to this landscape here, I would call it? Yes, I just want to... Next one here. So here we have, first of all, the content of the presentation, but first of all, I want to take a look on the figure here on the right. If we take the right box here, well, what many regions are looking for is to have CO2 emission reduction, but also increasingly important is the question about improved energy security for the regions, and also to minimize grid investments, especially for developing countries. And of course also for countries that need to renew their electricity grid. And how can you do that? Well, first of all, you can improve the energy efficiency, and we see that already done in many places. Much legislation takes care of that also. We are basically talking of that every second presentation here today also. We want also to be able to enable the variable renewables, wind, solar, and so. And we want to reduce peak demands, because all these factors can basically support the three others, which are so important for our society. And the good thing is actually that our industry can support that. Instead of being only passive, looking at passive usage of energy and optimizing the energy performance, we can actually also play a role here, and that could lead to a real nice win-win situation for society, for industry, and for the consumers also. So first of all, I will today then focus on the supermarket side application here. I will take a look at flexibility, because flexibility is really what this is about, how supermarkets can add flexibility to the grid. Take a look at what are the potentials if we aggregate all supermarkets. I have some numbers from Germany and also an EU perspective. And then the second step is actually also to look at thermal networks, not only electricity but thermal networks. If we are able to connect supermarkets to thermal networks, what will that be? And I will show you a case study, a recent case study where we have actually connected a supermarket to a district heating grid and see that this is actually functioning. It's very simple, but supermarket likes it very much because they now get a nice income on selling their waste heat to the district heating grid. So supermarket as a smart appliance, well, first of all, I said supermarkets use a lot of electricity, so as a sector they are interesting, but as a sector they are also interesting because they are addressable. And they are addressable because you don't need to go out and invest in a total new supermarket store to become a player in the flexibility market here. What you need to do is actually add some intelligence to your system, and that then you're more or less up running. Today, when we are talking about smart grids, we learn a lot about private homes, how we have to change all our equipment in the home so it can be flexible and smart. Well, I think the time constant for doing that for a total society is rather long. But here we have something that is actually much more addressable. And the existing retail service structure is perfect to leverage on here, because many supermarkets, they are already within a network. They are controlled by big supermarket chains also. Yeah. Next slide here. So flexibility in supermarkets. What is this about? First of all, we know today that the situation in the grid, the stability in the grid, is increasingly becoming more and more critical when we have a lot of wind, when we have a lot of solar power. We know that it's not always as predicted. A wind front may be delayed or come before you planned it. Solar power may also not act as it is planned. So can we support the grid in shutting down our compressors very fast? Actually, we can. If we are in control on the temperature situation within the supermarkets, we have shown that it's actually possible, if you have the right setup, to within seconds to react on a command from the grid, and thereby add flexibility. And that is actually what many of the utilities are asking for today also. Another point where we can do a lot is on the defrosting in the supermarkets. Here we are talking about a little bit longer time frames. If we want to plan and know maybe 1 hour before that there will be a critical situation, we could be able to either forward a defrost, or we could postpone one and thereby add flexibility to the grid also. If you aggregate your stores, if you have many supermarket stores, then basically what you will see during the day is that the defrost consumption is more or less constant, not for a single store, but for many stores. It means that you can reduce it if you are in control of it in that sense here. And then we have also the little bit longer period here where you can make directly temperature storage. You may cool down your cooling cases a little bit more, and thereby simply adding a storage of compressor work, which you can draw on at a later stage. So if we try to put some numbers on these three flexibility things here, just take a normal supermarket, as I will show a little bit later here, and you do some assumptions on that, then you will see that actually typically within a period of where you can accept not running with your system here, that you will be able to reduce your power with 100 to 60% within a time frame, depending on how much you want to reduce it, but 15 to 25 minutes is definitely not unrealistic. And also the time without defrost could be a window of 90 minutes. The flexibility in defrost will then add up to 13 kilowatt. The cooling flexibility would be 40, and you would have for a single store about the 50 kilowatt of flexibility that you would be able to address here. If you are a chain with 500 stores, this could add up to more than 20 megawatt, which is quite interesting for utilities. So just to compare some big numbers here on the supermarket, because if there are regulators here, they would maybe be interested in that. Take a country like Germany, where we have around 30 million square meters of outlet here. If we add that up, then they have around 10 terawatt hours of electricity consumption per year here. If you compare that to the amount of wind energy, it's 51 here, solar 26. It's numbers that are quite well aligned, I would say. So these numbers fit quite well together, enough to say, if you just add the law of big numbers here, that supermarkets could really address something if we want to do it. Even more on the European level, I would say, because Germany is above the average when we are talking renewable sources for the electricity grid. So the next step is actually then, first of all, we were talking about the electricity grid here, but why aren't we trying to combine the electricity grid and also the heating grid. Well, this has some very good advantages because district heating, and I would also say district cooling networks, are born as big storage facilities. It's something that you get for free when you connect to them. We know also that the waste heat from refrigeration can be exported to these grids if you connect to them, and even that the supermarkets can add on their flexibility, and they can be storage enabled for heating and cooling. I will come back to that a little bit later also, how they can even improve their position as it is today. A case study on a district heating connectivity. As I said in the beginning, we have, during this winter here, we have made an installment where we have connected a supermarket in Denmark to the district heating grid. It took a little bit long time, I would say, because the local heating utility, they were not so interested in the beginning, and I think it's what you normally experience is that there will be a notorious no in the beginning, and also the statement that, well, it must be in the summer, then you can deliver most heat. Right, we said it is in the summer, and said, well, we are not interested. They came back 2 weeks later and said, now we are very interested because we found out that our system is not running very efficiently during the summertime. So if you can add some decentral heat generation, then we would be very, very satisfied. So the store was ready to do this, and actually it only demanded a very, very small change in investment here. So actually, what we do here is that we have a return line temperature of the district heating system around 35 degrees, and what we return to the district heating line is 65 degrees, and there is a counterflow heat exchanger doing that. So the CO2 leaving this heat exchanger will have a temperature around 40 degrees, which is nice because then you can still use it as a heating source for the space heating in the winter. So the district heating will not compromise your space heating needs during winter. This is a schematic outline of what has happened in the store. Previously, we had a heat recovery system where we had the sanitary hot water system here, and we had the space heating here. So what we did is just adding a few valves here, three-way valves on the very warm heat recovery side here. And we had also to add a special pump that can overcome the district heating differential pressure. But I would say a very modest investment. And this system has, and you can also see it's a rather old booster system. It's not parallel compression at all in this system. But this system has now been running for 4 months. And we have now, because of course the supermarket get paid for selling heat to the district heating system, so there need to be a very accurate measurement on how much they deliver. And we were very happy actually that they are able to deliver 10% more than we predicted. It's always nice to be on that side, I would say. And we can see that during the days of 1 week here, more or less constantly we deliver around 27 kilowatt for this relatively small supermarket to the district heating grid. So, and even in this case here, they had to compare, or they have to compete with the biofueled thermal grid, which is rather cheap. Still, they get an income for this around 6,000 euros per year. So, supermarket owner is very happy about this, and the district heating is happy also. And I think even society also, because we save a lot of CO2 emission on this also. Yes, final thing here is that this could even be improved because we know also from our measurements that the compressors are running with, as an average, 30% of their capacity during the year. And the rest of the time they're not used. And once you connect to a grid, why shouldn't you then utilize them more? Because this is an infinite heat storage opportunity. It would even be better if it was a district cooling place also. The supermarket already invested in these compressors, so we just need to find a way to really utilize the capacity. Of course, you have to take care of your COP in that sense that the numbers shown here was for pure waste heat. If you fall into the trap and just want to sell a lot, then you may compromise your efficiency and you have to pay too much in electricity. But there we have the smart grid that comes in with flexibility and prices. So I think that would really boost the contribution from the sector here, and I think also we should really take a much deeper look on this opportunity here, because actually, as you see, some of the numbers here in Germany adding even 14 terawatt hours in heating compared to the 6 terawatt hours that they can supply today. That is actually a very interesting opportunity. So coming to my conclusion here, supermarkets, they can play a significant role in new smart integrated energy systems that definitely welcome. They are addressable. We can do this, and we can do that relatively easily. It requires modest investments. It's a good business case for all, win-win situation. The heat recovery, well, we need to take the next step also to connect to the supermarkets with, if we have or plan district heating, this could really be a very good enabler for even getting more out of the smart grid. And then finally, take a look at the extended heat production. Use the unused compressor capacity. So thermal and electrical flexibility, they will at the end support each other and make an even better business case here. So this was my word, and I will say thank you and take some questions.
Thank you. C'è qualche domanda su questa memoria interessante? Prego.
Hello. Was very interesting presentation. Thank you. I would like to ask, first of all, let me see if I get the point. The district heating network will be a low district heating temperature in this case. Okay. In the reference that you, in Denmark, your experience in Denmark, how, considering that usually the network is built from the company that produced the hot water, and in this case probably the company that has the CHP plant, in this case how has managed the conflicts about the fact that the company have to decrease the temperature and at the same time that to permit to other people to provide heat in the system, in this case supermarkets, how it is this conflict is creates, how does it manage in your real case? Thank you.
I'm not sure I got everything here, but the temperatures of this district heating grid is around the 65 degrees. So you're right, there are district heating grids, mostly older district heating grids that are running at higher temperatures. That's totally correct, yeah. But what we see is that normally, and all the new district heating grids, they are actually running at these temperatures here. And if we look into what we call the fourth generation of district heating, then it may even go down to 40 degrees. Because efficiencies of all processes, they simply become much higher if you are running with lower delta T's.
Sorry, my question was, I mean, since the company that usually has the CHP plant, they invest to build the grid, to transport the hot water. In this case, what's the economical conflicts between how other people should be supposed to supermarket to get inside his network? You know, since they want to, of course, have the economical investment back from what they built for all the network and etc. Why? I mean, how we can solve these kind of conflicts that permit other as supermarket to join the network?
Yeah.
Okay.
You need to have, of course, you need to have a supply agreement. In most cases, they would actually be happy It's a price, of course, it's a price negotiation also. If you, for instance, have a plant, because you need to fuel your CHP plant also, or you may have a gas-fired plant. If you have a gas-fired plant, I can promise you that they will be more than happy to receive heat from a supermarket. You are very competitive. Yeah.
Maurizio Orlandi from... Shall I raise the question? Okay.
I have a comment to your nice presentation. Okay. And maybe in addition to your comment or question. In Sweden, Fortum, the district heating company in Stockholm, they have opened up their grid for additional supply at different temperature levels. Why is that so? Because instead of building a new plant, which costs them billions, which is running only 2 months a year, they open up the market, and on a kind of on the internet you can get the rate for the next day's supply. So if you are able to supply heat at different temperature level the next day, you already know the day before how much you get for the heat. And this is the flexibility which is a great chance for supermarkets actually to come into that business. Also in the winter and in the summer, of course, it's more efficient to use the waste heat than having a plant running in part load operation many times.
Yeah, thank you for that comment. Totally right here. Two comments to that. If that supermarket would have been connected to the Stockholm grid, they would have earned the triple, I think. That's one thing. The other thing is that there are many ways of connecting to a district heating grid. If the district heating owner will not accept the 65 degrees, maybe he will have 90 degrees, then you may have a possibility to just increase the temperature of the return line also, which could also be an opportunity.
Was there another question?
Yes, very quickly, Maurizio Orlandi from EPTA. I'm just wondering, without thermal grid, in the first part of your presentation, you've spoken about supermarket can cooperate with smart grid, moving electrical load. And in one of your tables, you specified that from 15 to 19 minutes is enough to have an improvement of the smart grid. Could you explain a little bit the detail of this time? Is this short time helpful?
Yes. First of all, the faster you can react, the more value you have in your flexibility. And you can go into the homepage of National Grid in the UK, for instance, and you can have a look at what they really pay for flexibility. They don't pay for energy, they pay for flexibility. It means that you will get a yearly income providing your flexibility. We have seen these rates also in New York City, where they had very detailed schemes on that. So if you can react very fast, it's a high value. If you just plan so that you lower your consumption during peak hours and so, then of course the payment is not so high. But the more critical the situation is, the more that they don't have to use what they call the spinning reserves, the more value you have. Yeah. But again, it differs very much from region to region. Yeah.
Okay. Oh, please. While it's coming, I have a question. Do you think that why limit this idea to supermarkets? For instance, here at Politecnico, we have a project going on to do exactly the same with the plants inside the Polytechnico. So
I think we should not be limited.
Have a kind of conversation with electrical grid, yeah. And we have a district heating grid inside, and of course it's possible to obtain this gain and increasing the flexibility. So yeah. I think this is a bright idea that can be broadened to a lot of different possible consumers.
Yeah. I totally agree, and there are a lot of big unique consumers. And we see that in many places they already may have an agreement for many years actually. If there is one very big electricity consumer, then they have some agreements already. Yeah. But you're totally right, there are many unique opportunities.
Because in the old times there was only this possibility of being interrupted.
Yeah.
And you pay less the gas if you accept to be interrupted, and the same for electricity.
Yes.
But nowadays it's much easier to have a fast response and much better facilities.
Yes.
Please.
Yes, you spoke about district heating, and I didn't understand very well, but probably there is a potential for district cooling. This system could be applied for district cooling, as a recovering cooling, not used for supermarket, and be used in the district cooling system.
I'm not sure I got... well, maybe, I think, of course you can, if there is a district cooling system available also, especially for the, when you have extra capacity available, then it would be really a good situation, because then you should not throw away anything of your compressor work, basically. You could sell the cooling and you could sell the heating also, which would be the best situation. It's still, unfortunately, rather limited where you have both systems installed, yeah. But for instance, many new cities, they plan with having both, or parts of cities plan with having both district cooling and district heating. In that sense, it would be fantastic, yeah.
Ok, se non ci sono altre domande